did. And hopefully we'll have a break for 15-20 minutes in between. So we'll have 3 presentations, then a quick break, and then 2 more presentations. The second page, guys, I do have, every team is presenting one aspect of the project. So as they present, please look at the themes of their presentation. Could be power, lighting, low voltage, estimating, you name it. So these are the themes. So please have a quick look at that one. And for you guys, it's front and back, this page. And the last page is, we have a quick evaluation, very easy. Feel free to write anything. The last page has the team as well as the members of that team. If you can just sketch from 1 to 10 what you think of the team as well as the individuals. So I really appreciate that one. Take a few seconds to do that as they go through it. Oops. I know very few of you guys have not been here before. So Danuri has been offering electrical construction design and management for 14 years. Out of these 14 years, Gary Ryman and I have been 10 years. So we have graduated for the last 10 years. Any victims that came to you, probably any employee is one of our victims. The way we do it, guys, I'm going to let you enjoy the presentation, but I would like to introduce at the end of the presentation, we're moving to semester system. So we're changing a few things that we would like to get your opinion about that one, because we want to continue to do the same quality of education that we're providing for the industry. You guys are here today to witness presentation. We have a 25,000 square foot industrial building with manufacturing floor. The students are supposed to and have done the power, the lighting, and the low voltage for this 25,000 square foot. There's bus ducts. The electrical size of the project is a 4,000 amp 48277. So for those of us who, that's how we size them. It's a 4,000 amp switch gear that we're dealing with here. So the students will walk you guys through all these presentations. I want to highlight a few things that we did that I think, being an engineer, I think it's a little bit, we pushed them to the limit. We did power tools for window, SKM, believe it or not. We introduced into SKM, power tools for window, coordination, short circuit, load flow, introduction. So it's really nice we have a license for it to use it. So that was really a highlight of what we do. Generator sizing, big deal for us to size a generator. The project is backed up completely by generators. We have 2 1.5 meg generators for this project, so that was a big deal that we use software to size it. Lighting calculation, complete lighting calculation for the project using Visual, Lithonia Visual. We did Amman energy calculation, guys, Minnesota Energy Code calculation. ComCheck is the software that we use, as close as we can get to Minnesota Energy Code. So these are another highlight that we did. And of course, all the design and drafting has been, this project was done in Revit. And that was a major challenge for all of us. And I'm sure you guys will enjoy the Revit work that the students have done. One more thing I want to highlight, tours and speakers. I'm going to highlight 10 things that we have done this quarter only. We toured Michelle Cooley Erickson. This project is adopted completely by Michelle Cooley Erickson. Means every week they come over here and they observe the students' work. So that's really nice. So we have another, instead of listening to Chad for 1 whole year, they have another set of eyes to look at their work. We visited Cummins, and they parallel 3-4 generators, I think 2 meg each, put them online in front of all the students. That's a major thing for all of us. That tour is already on our YouTube channel, if anybody will watch it. Great presentation, putting their plant online, packing it up by the generators and doing the paralleling and soft loading the plant onto the generators and back into the grid. So that was really cool one. We visited Boston Scientific. The project that we have right now is modeled after Boston Scientific, so we had the chance to tour all these manufacturing facility in Boston Scientific. Aliyah's data center right here. We visit the data center because we have a part of a data center in this project. Davis & Associates, since we do lights, Davis & Associates specialize in lighting, so we visited Davis & Associates. They gave a great presentation about lighting. We did lightning protection on the top of the building, so we invited Thompson Lightning, and they gave a great presentation about how to design a lightning protection for the building. Square D, we're here to talk about switch gears and power circuit breakers and panel boards and switch boards and the difference between all these. Low voltage contractors, we're also here to talk about fire alarm security, phone data, and clock system, master clock system in this manufacturing floor. So that was really great to have him here. We went to Midwest Expo. All of you guys were here, probably went to it, so that was a great presentation too. We toured EMI. The last thing that we did is we toured EMI, the custom design switch gear, so that was really nice. They get a chance to stick their hands into a 15 kV switch gear and look at the difference between a 480 600 volt switch gear and a 15K switch gear, so that was really cool. So I thought to highlight this. I know the rep Chris is here for Michelle. I would like to thank Michelle Cooley Erickson a lot because they've been really instrumental in the success of this program, and we invite all of you guys to chip in that one too. So that's all what I have. I'm going to talk about semester at the end, so I'm going to invite, without further ado, I'm going to invite Dustin to start the presentation. So thank you.
Good morning, everyone. Thank you, Chad. My name is Dustin. Welcome to the Electrical Construction Design and Management Program Class of 2012 presentations. This is the sixth and final quarter of these presentations for these bright and well-rounded students. I have had the privilege to work amongst these fine students, and over the last 2 years, I have noticed that they are all hard workers and that they help out each other when one struggles. If I were to sum it up in a couple words of what I think of my fellow classmates that they give on a daily basis, it would have to be perseverance, dedication, and respect. I want to wish you guys all the best of luck in your future endeavors, and I know that you will do great, whichever route that you so choose. Now, to get down to business. For our final project for this year, me and my classmates were instructed to design a complete electrical system of a 25,000 square foot commercial and industrial building with a 25% future growth. We were divided into two groups. We were divided into teams of two. Each team was to complete the entire project in 12 weeks. And according to the design requirements for what we had to accomplish, we had to construct a project schedule, the design drawings, which were done in Revit, load calculations using Excel, estimation using McCormick and AccuBid, Minnesota Energy Code calculations using ComCheck, generator sizing using Cummins, lighting calculations for using Visual, power system analysis, power tools for Windows using SKM, cut sheets, and PowerPoint presentation as you see here in a minute. And each team will present a portion of the project. As far as the agenda goes this morning, we will start with teams 2, 3, and 5 to present. And after those teams will go, we will take a 10-minute break. And then after that break, we will have teams 1 and 6 to wrap it all up. First team to go will be Philip Flores, who currently works at Elliott Contracting, and Rob Nordstrom, who is currently interning at Michelle Cooley Erickson. They will be presenting the overall layout of the project, as well as power, riser, power operation, and bid modeling for the project.
Good morning. My name is Rob Nordstrom, as Dustin just said. My name is Phil Flores. Today I'm going to be going over the industrial project sheets and give you an overview of all the sheets that we had. E1 is the title sheet, basically your table of contents for the whole job. E2, we got your symbols. If needed, you refer here to figure out which symbols mean what. I know that I've seen things that looked like a receptacle but was square and it was an actual GFI and it wasn't in wire mold. So your symbol list definitely helps you out. E31, here's our power riser. It entails showing our panels, transformers, generators, and gives you our feeder schedule. E32 is our low voltage riser. It consists of your fire alarm, security, your phone and data, and your master clock system. E4, so here's your site lighting and power. E5, that's our first floor lighting. E6, we got our second floor lighting. E7, we have our first floor power. E8, our second floor power. E9, we have our first floor low voltage systems. E10, our second floor low voltage systems. E11, our lighting plan. E12, we have here our panel schedules. E13 is our equipment and our light fixture schedule. E14 is our electrical details. It's got our speaker system, how to mount the speakers. E14.1, we have our lightning details. E14.2 and .3 are also lightning details.
Onto our power riser. It's basically a 2D representation of our equipment, and then we also have our detail lines connecting all those dotted for underground, and then depending on your structure, you have your levels. If you go up on the high rise, you'll see your panels climb the high rise. Also with those, we'll have your keynotes specifying your amps, your parallel sets, your number of conductors, size of conductors, your ground, neutral, and your conduit used for every step of that riser. We start out at our service, at our transformer. From there we move on to our terminal box. It's being fed with 480-277 three-phase 4-wire. I believe we did 11 sets of 500 KCM. Then we move on to our 4,000 amp switchgear, and it's backed up with a parallel set of generators, and it also goes to our life safety panel too. From our 4,000 amp switchgear, we feed our high voltage lighting panel at 200 amps. We also service our transformer, which cuts our voltage down to 208-120 for our receptacle panel. And we have a mechanical panel that's high voltage at 350 amps. We also have another mechanical panel that jumps up to the second level at high voltage, servicing all of our second level mechanical equipment, including our exhaust fans, our chillers, and so on and so forth. Also from the switchgear, we have our UPS, which services our two PDUs for the backup redundancy. If one goes down, the other one will pick up the loads. From there, we also have our bus ducts, our high voltage 480 at 1,000 amps. We have a transformer cutting our voltage back down to our 208 for our lower voltage, so we can service multiple equipment on the manufacturing floor. And then we also have our ATS, which will switch back and forth between our main and our generators for emergency power, which will service our egress lighting, our life safety circuits, including our duct dampers and so on and so forth. A few cut sheets of our power equipment. We got this is a PDU. Shows a few different sizes. Some basic information that comes with cut sheets: our capacity, your inputs, your outputs, your environmental factors, your battery life, how long you want to back up your systems for, till your generators can come online, and, or if you just want a quick save and then shut computers down, depending on what kind of operations you're running. Also have our circuit breaker, our Magnum Power circuit breaker cut sheets. Has your current time curve right there. Your long time, short time pickup, all be adjusted. You see your plug on the back side, confront all your adjustments, tells you ins and outs for everything you need to know. Back onto over here.
I think back in the mid-80s or so, I think this was just a thought, a dream. And with AutoCAD, they sort of made it a reality, but with the software we have today, we can completely take it into 3D models and have first-person walkthroughs, give you the ability for clash detection. We didn't have the mechanical prints for this, so I couldn't run a true clash detection, so I used it for basically clash detection for the architectural and misplacing items, to where when we placed our lights here, they associated with the first floor, so that's where they ended up in the catwalk in the manufacturing room. We have a cable tray where we had to figure out exactly the heights of where they needed to go. Here we are fixed. I got them raised back up. Cable tray is where it needs to go. Definitely used it for proper placement. Here's some more cable tray going through a wall. We have some on top of the catwalk above the light. Here it is changed to where it should be going. Here, it was basically my designer error, forgetting to flip a Revit into a 3D model and then importing it into Navis. So when I brought it in, I ended up getting light poles like that. So I flipped back to Revit and I'm looking at the families. I'm wondering what's going on. Is there just a base here or whatever? But then we were informed of flipping it into the 3D model and then re-importing it. I think we did this with each phase, and this is with the site lighting, which was E4, is when we very first started bringing the models in. And that's what it's supposed to look like with lights. I use it kind of for before and after for a rooftop. There's the chiller tower, the cooling tower, and the exhaust fans, and these little white dots. You can kind of see the lightning rods placed on there. And I just really used it for proper elevation and coordination, to where now we got everything working right. Cable tray above the lights, so they're not casting down a shadow down on the floor. Got the bus ducts. We have a 480 and a 208, which they crossed each other, so I need to offset them so they can flow evenly. And that's it. Sorry.
As the industry grows with Revit, we have unknown errors, can't obtain permission to edit elements, and fatal errors occur. I know we're all growing. These are some of the headaches that we encountered with Revit, and then it always wants to close as you want to make a recovery file, and you got to merge in with your others. As our families grow, so do we. I'm glad we got over these headaches now instead of in the industry. Are there any questions? Thank you.